Hello, my loyal subjects, and welcome! Today we're going to be talking about how to actually make an UberShader in Blender. And we're going to start off really simple. We're actually going to be talking about it in the context of physically based shading. If you're not familiar with my previous tutorials on this, please go back and watch them, because, again, part of a series. So, what we're going to be talking about is first how to build a workflow, and then at the end I'm going to talk about a little performance trick that is really nice for making your UberShaders run really quickly, or essentially about as normal, at normal speed, you know, what they would otherwise be if you composed them by hand using the techniques that we previously showed. So, what does our current workflow look like? Well, it currently looks like we're dropping down diffuse nodes and reflection and doing stuff like this, and we get these lovely little shaders. So this is a dielectric shader, and we have to compose our shading kind of every single time. It's a little bit tedious, but we can make more interesting nodes. For example, we can create, we can create like a dielectric node, and at the end of the day, what this is all about, what UberShaders are about, is making your life easier. They are a convenience. Their job is to be a convenience. So, all you have to do, really, to make one of these is just go in, do whatever you do quite often, whatever shader you find yourself repeatedly making, and just hit Control-G on it. And then you just expose the values that you want to expose. So, for example, with here, I can go and I can expose like a color, a roughness, and a normal, but we also need this specular exposed over here. So I'm going to go in here. I'm just going to move that up a little bit. Both of these should use the same roughness because I like them to match. I like diffuse and specular roughness to match because, frankly, it just makes the whole authoring process a lot easier, and plus it matches what most applications end up doing. Now I can go in, I can adjust my roughness, I can adjust my color, I can make my specular higher if I want, or lower, as the case may be. If I'm trying to approximate like a polarizing filter on a camera, I can do like a specular of 0, which is something that you'll often see on like product visualizations, for example. It's like they'll use a polarizing filter to strip out glare, or like light bouncing directly at you. Anyway, I won't get too much into that. That's more in the photography side of things. But anyway, so with this in mind, we can actually go in and create our workflow. You know, we just need to pick tasks that we do constantly that we would like to make, kind of like to make them go faster. So in this case, I've created my basic suite of nodes. I've created a glass node, which, as you can see here, is just, again, exposing the values I want to have control over. Now, it's important not to go overboard with the control because at the end of the day, we still have the ability to compose these manually relatively easily. So if we want absolute fine-grained control, you can do it. Like, you can just drop down these nodes again. We have low-level. The low-level stuff still exists. These shading nodes still exist. But we also have these lovely shaders which can help us out. These little UberShaders, if you will. Now, we're not really in the UberShader territory quite yet, but you can see here I've got a glass shader. This is a nice little glass shader. It's just refraction and reflection, and I just set it up this way. Again, there are alternative ways you could set it up, and a lot of it's personal preference. Some disclaimers: I'm not a huge fan of huge walls of sliders because I don't like exposing all the properties, personally. That's just a personal thing with me. I find it much simpler to have simple to use utility nodes, and then if I want to get really advanced, I can actually go in and lay down the bare, like, more intricate nodes. Because often, if I want to be that precise, I'm going to have a lot of extra nodes in there anyway, so it's actually useful to me to be able to take these and space them out. Like, take them and space them out on the graph and say, like, okay, well, all my reflection stuff is over here, and all my refraction stuff is over here. Maybe a better example of this would be like a clear coat or something, metallic and a reflection, we've got here, so. there's my clear coat shader. So again, like I would want to have all my metallic layer stuff over here and all my clear coat stuff over here. So again, that's just a personal preference of my own. You can, of course, design it however you want. If you want to match a specific game shader or something, again, you'll compose these as you will. Now, I personally like to build first materials, so I have like dielectric. Metallic is already sort of a material. You know, you only need one of them to get the shading of a material. And then, of course, I've got glass in there as well. Now, each of these, I might want to have, I can actually combine them into a single node. And this is where we really get into the UberShader territory of an UberShader that does a bunch of different things. And again, it's really straightforward and simple. Each of these is a material. And notice I've just exposed 3 different shader outputs. This has a couple different advantages. For one, it runs significantly faster. I'll get into that at the end of the video. It's a bit technical about why it runs faster, but has to do with how the actual code is compiled, because these are technically code. This is a visual way of programming your shaders. So anyway, but if we crack this open, you can see it's just my dielectric shader, my metallic, and my glass, all in a node. Now notice I haven't exposed everything. I haven't exposed stuff like the index of refraction for glass. I have not exposed stuff like the dielectric specular. I have not exposed things like the metallic rim color. The reason being, I have those nodes. If I want to make a metallic that has a very specific rim color, I go and I lay down a metallic node. Like, it's that simple. On the other hand, if I want to create, for example, just a basic material, you know, if I just want to throw down a really simple basic material, it can often make more sense to just have these 3 basic color values. They're easier to manage, and most of the time you'll get any material you want with these. And honestly, that's probably what you want to do most of the time, because these are the main materials properties that will vary from every single surface. You know, how bumpy is it, and what color is it? So, on the other hand, stuff like specular, pretty uniform, changes a little bit, but not much. So, again, be careful with that. But again, we get a lot of freedom with this, so we get a lot of control, freedom, we can create and play around with a bunch of different shaders. Like, this looks gorgeous in red glass. Like, look at that. That looks amazing. And again, this is just simply nesting, one atop another. So, you just hit Control-G, group it, and click and drag your little outputs out. You know, just, or little inputs. So, this is how you expose stuff, and this is how you create UberShaders. And remember, they are a workflow thing. They are not something where you can have a distinctive, this is my UberShader, and this is my shader that does everything. We can create an UberShader that does a lot of different things, but we also need to remember that we have these nodes in here. If we need to throw down a metallic node, we can. But if you do want to make an UberShader that does everything, you can. I could go in here and say, and expose every single property. I could go in and say, okay, well, I'm kind of tired of this whole, you know, rim color, not having control of it thing. So I'm going to say metallic rim color. And then it can say, like, okay, well, we've got our specular. And then we've got, we'll also use the specular up here. And I can say, like, index of refraction. Or something like that. So, there, now we've got a more intricate shader. And if I go here, you can see I get more fine-grain control. And again, this is all a personal preference thing. I know these nodes really, really well, so for me, jumping in and actually throwing down a metallic node makes more sense when I'm thinking of a very, very specific metal material. If I'm just concepting and trying to get stuff out, I'll often use something like a surface material, because this kind of stuff, you know, just something that's generic. And again, this avoids having mixed shaders, which means we're not running both the shaders, which means our shaders run quicker. Plus, it doesn't even end up in the code, so you'll take up less memory on the graphics card. Again, it just makes the whole process a lot simpler. So, now, hopefully, this has helped you out. And we're going to move on now to a little bit more of a technical section, warning, there's going to be some technical ahead. You know, there's going to be some tech stuff. I'm going to be talking about how Blender works internally, or how any graph editor works internally for that matter. So, Blender is a graph editor at heart. You know, or not Blender, but this Cycles material editor is a script engine. It's a script editor. It is something to allow us to write code. And yes, we are writing code. There is not really a question on that. We're just doing it with some nodes on a graph, because nodes are amazing. And so how does it turn it into code? Because let's say we went in and we threw in a diffuse, for example. Let's start off really simple. So we threw down a diffuse shader, just basic clay pass diffuse shader. Well, here's one of the cool things that we can actually do. You know, if you're a coder and you've built your node UI, well, we can compile this into code. And the way we do this is with this little material output. So it's going to start off here, and it says you need to ask some questions that you're going to allow the artist to fill in. In this case, what shading does the surface use? What shading does the surface use? Well, we connect up the diffuse shader to say, hey, it uses the diffuse shader. And each one of these is kind of a question. And, you know, okay, what color is the diffuse shader? Well, we said white. You know, it defaults to white. And we've also got a roughness. It assumes roughness of 0. And it's got a normal, which is what direction the surface is pointing, essentially. And this assumes that we're using input, geometry, normal. So, we've got geometry normal there. So if we go in here, we can think about how the code starts off. It's a question. Surface equals what? You know, what does surface equal? Well, what it needs to do is it needs to follow this line. It says, okay, is there anything connected here? And it's going to follow this line down, and it's going to get to a diffuse shader. Well, a diffuse is a built-in thing. So we're going to say diffuse. Now, diffuse isn't just you know, something that just sits on its own. It requires a little bit of information. It needs to ask some questions of its own. It needs to actually ask some basic questions, like what color am I? How rough am I? And what direction am I pointing? So in this case, we've got kind of a light gray. And again, I'm just writing pseudocode here, but this is actually very similar to what you might otherwise see. So light gray, roughness of 0.0, and our normal will be geometry normal. There. Or for simplicity's sake, geometry dot normal. There. There we are. So here we've written some code. But what if we modify this? What if we go in and we say texture, Verneuil, and we plug this in here? And then, I don't know, I want this to tile 32 times. So here I've created, you know, okay, whatever, I've created the thing and I like it. So what it's going to do is it's going to go in, it's going to do that same process following the connections. But instead of just picking whatever the hell was in there by default, for our diffuse shader, it's going to ask another question. Notice it asked what color this is. Well, it's the color of the Verneuil texture. So it's going to say Verneuil, which again asks some questions of its own, like what is our coloring? So our coloring is intensity. You know, that's the intensity version of Verneuil. You know, this sort of splotchy one, rather than the one that looks like stained glass. And then we've got a vector, which by default we're just going to call generated. This is the, you know, or texture generated or whatever. Texture dot generated. So there it is, and it's tiling 32 times. And then it's going to go down here to our roughness. It's going to say, well, roughness is 0.0, and then our normal is geometry normal. So here's what it's doing. It's generating this code, right? It's just going to keep doing that. But notice, there's something interesting that happens when it asks these questions. It follows a line. As in, if I break this line, even though this node is still here, it's not going to get to it. It's going to say, well, what color is the diffuse? Well, it's light gray, and it's just going to stop there. This Verneuil node, because nothing's connected to it, technically never gets compiled. It never hurts performance because it doesn't technically exist in the code. So, anyway, that's how this stuff gets compiled, but it gets even cleverer than this when we start thinking about it. Again, this is a little bit technical, but we can abuse this a little bit more because there's a simple thing in Blender that I have been using quite a lot that we have just been talking about. Node groups. Node groups. Their amazingness. What is a node group in code? Well, it's nothing. All a node group is just a shortcut for us. It's something for us to dick around with. So for example, let's say I swap out this diffuse shader for dielectric. And I'm going to go a little bit faster here in writing out the code file for this. And again, this is all written in a computer program to generate anyway. It's the code being written by other code. You know, that's the general idea. So it's got a script to generate a code, the code from this. But we're going to be pretending we're the computer program going through it. So what's it going to do? Well, it's going to wander along this line, and it's going to get to our node group. Well, our node group isn't just, like, a thing that it can run. It needs to know how it works. So it's going to crack open on the inside. Because the node group technically doesn't exist. It's just a shortcut for us. So it's going to go in, it's going to say reflections. Well, that's also a node group, so let's crack that open. Well, it's going to get to a mix shader. So surface equals mix. And that's, notice here, even though we've gone through two node groups, none of it's shown up in code because technically the node groups are just a way for us to copy and paste. They're essentially copy and pasting for us. Really fancy adaptive copy and paste. So we've got a mix shader, but what is it a mix shader of? Well, it's shader A mixed with shader B based on some factor. So it's shader A, which in this case, it would go out and it would find this diffuse shader. And it would say diffuse. And I'm not going to go any further into the diffuse here, but you get the idea. It would go up and say light gray and all this stuff. But then it's going to go in here. It's going to find this glossy shader. It's white and has whatever roughness we define. So it's going to say it's mixing between diffuse and glossy, which is white. Its roughness is 0 in this case. And its normal is we're just going to say normal for now. And then what is it blending based on? Well, it's going to go up here to the mix shader, and so on and so forth. It's going to keep doing this. Node groups, by their very nature, don't exist in code. They're just copy and paste. They're just copy and paste for us. It's just following these connections. It's ignoring node groups. It's just using them as a way to jump in and out. They're just modules for us to link together to generate code. They're just copy and paste. So, what does that mean? What does that mean for us as creators? If we go to surface, our little surface shader we made here, what did we do here? We exposed the shaders directly. We didn't put them through mix shaders and expose the sliders. On top of this giving you a bit more control, because if we want to do like a metallic slider, for example, we just mix between dielectric and metallic. On top of this giving us a little bit more freedom of control, this also makes it run way faster. Reason being, the code never shows up. It is not having to calculate both shaders. So, anyway, what we're actually doing, let's walk through this again, and I'm going to go much faster here. So, it's going to start off at surface. It's going to follow the connection into our surface shader. It's going to go to dielectric. It's going to go in here, it's going to do all the gunk we've got in dielectric. So, I'm just going to write this out as, oh yeah, I closed my notepad. That was not a good idea. So, it's going to say, we've got a surface. In this case, I'm just going to sum up the entirety of dielectric as dielectric. So, and then it's going to go in here, and our color is sort of a light gray. Our roughness is 0.0, and our normal is normal, and specular is, you know, our specular over here is whatever the hell. So, I don't know, 0.033. There. I have written out the code. I have written out my code, and here we are. So, and obviously I've oversimplified here, but this is a general, you know, this is kind of the way it was compiled. And notice, we've gone through, we followed our connections out. We've followed our connections out we've created all of our information, but notice I don't see any metallic in here. Our node group has a metallic in it, but again, we're getting into that floating node scenario, where it's acting like it doesn't exist because nothing's actually connected to it. We see a line here, but there's no line connecting this metallic to anything over here, which means it doesn't exist. It looks like it exists. It's got properties over here, it's got properties over here. They're the same node. But the commands inside of it, the code inside of it, does not exist. You know, bits of it don't exist. This entire bottom half here does not exist in the code. But the moment we hit Control Shift and click, it's now only the metallic node. Our dielectric code just was recompiled and didn't show up because it's not connected. This line goes out and is just hanging out there. It doesn't exist. It is never found when we turn this into text code, so the text code never gets created. So technically, this is the metallic script, and so on. Obviously, I'm oversimplifying here, and that's pseudocode. You know, it's fake code. But this is how we can make shaders really fast. Mix shaders, they actually make both shaders show up. Because if we remember, with our reflection node, notice we had diffuse and we had reflection in there. We had glossy and diffuse. And we had all these other nodes as well. All of these show up in the code because they're being mixed, they're reliant, they exist, quote unquote. As long as we have connection to it, it exists in the code, which doesn't necessarily mean that it is always going to cost something, but it will cost something a lot of the time. Your graphics card especially is pretty terrible at making yes or no decisions or quitting. It's really, really bad at saying, oh, well, should I be doing this work? Yes, or no. You know, an example is your graphics card, basically, most graphics cards can't efficiently say, well, if this is true, do this, if it's false, do this, which means they essentially have to do both and toss away whatever result you didn't want. So even if you've got a mix shader, theoretically, and it was, even if you were only saying use diffuse, it would technically use both. Now, that's not entirely true. Blender has done some really clever stuff to actually cheat around this. One of the things that they're actually doing, and I love this trick, this is one of those little minor intricacies with Blender. If you mix between two shaders, it's not actually mixing the two of them. It's not taking both results and mixing them. It's actually going in and randomly choosing one. It's not actually doing diffuse and glossy. It's doing one or the other. It's doing one or the other by swapping them out. So one pixel, you know, if I drag my camera around, I don't know if you'll be able to see this on the video, but there are certain really dark pixels and there are certain really light pixels. It's very noisy initially. That's actually because we use a mix shader. It's randomly choosing between diffuse, which is providing a very bright white result, and glossy, which is providing a less bright result. And especially if we look at glossy in a noisy state, it has a lot of black pixels, where it reflects something that is just dark. So, again, when we mix, it's just picking one or the other. Now, of course, the way it actually is rendering multiple pixels and averaging them, it acts like it's blending them together, which is really cool. It's a clever use of Blender. It's a clever way for them to allow graphics card rendering to still be efficient. But again, you're still spending that mix shader. It still has to figure out which one it should be using. And it still has to quit. You know, it still has to pick one and do it. And, you know, graphics card kind of sucks at that. It can do it, and they've managed to make it faster than it would otherwise be, and many other GPU-based renders flub this part of it. If you've used other GPU-based renders and had them run horribly, this is like one of the clever tricks that Blender has used to stay really, really fast on the rendering scheme. So, yeah, this is how shaders get mixed. But again, both bits of code exist, and therefore both of them cost a certain amount. Especially whenever your graphics card flubs and accidentally goes the wrong way, and then it has to go back, and your graphics card is just fiddly and not super smart. It's good at doing a lot of things, but it's not very good at doing complex things. So anyway, hopefully this has been informative, and hopefully this will keep you in mind. And just to also highlight why this is significantly faster as well, is like, okay, we've got our, it's not compiling the extra code. Also, the other thing is just mix shaders cost. They're not super expensive on their own, but when a lot of UberShaders have a tendency to get, like, just bogged down in the amount of mix shaders they've got, like, they end up having tons of these things. And I'm just going to run some calculations here. And for those of you who are super not into the nerdy stuff, I mean, just turn off now. But I'm just going to be doing a brief rundown of how many times this would get run, and therefore how many times it would cost you. Even if I was using this just to pick, like, whether I want a metal or dielectric or even, like, refractive or any of that, like, any of your on-off switches, basically, for, like, oh, well, do you want to use this shading model or this shading model? The reason why that's so slow is because these mix shaders cost a certain amount. It has to actually figure out which one to use, and it's clever, and it's figured out a way to kind of work around it, but at the end of the day, we're still talking about a cost you incur quite a lot. So, first of all, 1080p screen. So, 1080p screen is 1080, or 1920 by 1080. That's about over 2 million pixels. 2 million times, not that big of a deal. If you have 3 mix shaders or whatever, not that big of a deal. So a mix shader would be run 2 million times for each pixel. However, mix shaders aren't just run once. We have a ray tracer. So notice we've got samples here. These clean up noise by rendering a pixel multiple times, getting different results, and then averaging them. So at the end of it, even though you've got a bunch of noisy images, it'll average them out. So if we're rendering, for example, with my render settings and everything, about 256 samples, but for, let's say, an interior scene, I think the minimum you can get away with is about 1,000. But honestly, if you've got really good settings you've used, portals and all this kind of stuff, you've just cleaned everything up, I can get about 256. Even then, it's a little bit grainy, but you can kind of get away with it. So let's just go conservative here and say 256. Let's say you've got perfectly tuned settings. The best settings I've been able to find is that's about the minimum about what I've been able to get. So even then, we're only at about 500 million. Sounds like a large number. It is, but it's kind of, it's still not that big of a deal. However, there's one more assumption we're making here. One more hideous assumption. Light hits once. When rendering a pixel, it is not just running your shader once. It is having to send a ray into the scene to hit the surface, and then it has to figure out which shaders to use to figure out what color the surface is. But in order to discover what that surface is, it has to then shoot off some rays to figure out what the other surfaces are doing. That way it can figure out whether light is bouncing from one surface to another, and so on. And by doing all this, our light bounces come into it. So if I go to light paths, you can see minimum 3, maximum 8, and diffuse bounces of 1, and all this stuff. So let's assume, for simplicity's sake, that we're getting about 8 bounces, because that's actually the amount we would normally get. So, because we're shooting off some glossy bounces that'll bounce quite a few times, we might have some glass shaders, or let's say 6 for the sake of being absolutely conservative. And be aware, I'm being really conservative with the numbers here. There's a ton of stuff that I've had to render with 1024 samples and all this stuff. Let's just be really conservative here, and let's just say 6. We're already at about 3.2 billion times. This is with pretty conservative settings. Minimal conservative settings here. That's a lot of times to pay for a mix shader that essentially works like an on-off switch, deciding what shader you want to use rather than just dropping down the according shader. So, again, it's one of those things that can speed up your renders a lot if you just actually sit down and take the extra time to build something that will, again, either go in and drop down, like if you want a glass shader, use a glass shader. Make your own custom one that's shiny and everything and does all the things you want, but just make a glass shader. Again, that can really speed things up. Or you can go and create something like this, where it's a bunch of shaders in a box, but they're all exposed, so you can just pick which one you actually want. Which one do you actually want? And that's essentially the important thing right here. And in a more realistic scenario, by the way, 1024 samples, 12 trillion, almost 13 trillion. Let's see, what you might need more global illumination, like 2 diffuse bounces. I don't know. Let's just say, we'll just go for 8 samples, because let's say you've got an interior scene. Interior scenes almost always bounce a bunch of times. So we had 6, right? So divided by 6 times 8. I don't think that worked. I don't think that worked at all. So divided by 8 times 6. Nope, that was correct. Divided by 6 times 8. Yeah, so anyway, we're about 17 trillion. That's a lot of times to run something that is functionally working like an on-off switch. That's like, yeah, that's a lot of times. And that doesn't add up to like a couple seconds of rendering time. Early on with the millions, possibly. Second or two. Half a second here and there. No, this is more likely to add up to several minutes of render time. And if you're doing an entire animation, that's per frame. That's per frame, by the way. So yeah, I mean, your computer can do a lot of work. And do you really want to add anything to that? So anyway, that's kind of a little optimization trick right there. Again, really nitty-gritty explanation. Sorry if I just bored the living shit out of you, some of you with that, because I know that's like really, really nitty-gritty, but it's information that not many people talk about, so I figured it would be kind of interesting to cover it and see, like, again, I'm not necessarily saying that you need to have all this complexity in mind. Like, this is just how I came up with this trick, because I happen to be a programmer, among other things, and I know about how graphs are compiled because I tried to make a graph-based coding system at one point, which I will probably one day work on more, but frankly, I love visual coding, and I like actual normal coding as well, so anyway. So, hopefully this, again, did not just put you to sleep, and if it did, I hope you were intending to go to sleep and not just feel like stabbing out your eyes. Anyway, peace out, Cthulhu Ftahen, goodbye. Have a wonderful evening, or afternoon, or whatever time of day it is for you. Goodbye.